All right, so here we are in the on question number 30. It says Rita is riding in a bike race that goes through a valley and a nearby mountain range. The table gives the altitudes in feet above sea level for the 5 checkpoints in the race. So once again, we're kind of talking about something that was very similar to a previous thing. So the first checkpoint, if you think about 0 as sea level, the first checkpoint, so let's say 0 is like here. So the first checkpoint of the race would be about up at 1,240 feet. Okay, and then you can see checkpoint 2 starts going up some more to 2,300. Then checkpoint 3 goes all the way down past 0 into 187 or so. And then checkpoint 4 comes up to 185. So it stays below sea level, but not quite as far down. And then back to checkpoint 0 to end the race. Okay, so that's kind of matching up. The checkpoint here is checkpoint 0. If we kind of just called it that, let's say, well, can't draw perfectly with a mouse, but let's just say that's kind of how the race is going to look. All right, so with that concept kind of understood, let's look through the different questions. It says the table gives the altitude, um, and it wants us to answer this. Which checkpoint is the furthest above sea level? Okay, well, we realize that checkpoint 1 is about here. Checkpoint 2 went to about here. Checkpoint 3 started going down and down and down to about there. Checkpoint 4 is about here. And checkpoint 5 is right here at 0. So which checkpoint is furthest above sea level? Well, that would be checkpoint 2. The next question, it says which checkpoint is furthest below the sea level? Well, there's checkpoint 1, checkpoint 2, and then checkpoint 3 has the biggest negative number. So checkpoint 3 is the furthest below sea level. And C is, what does it mean for a checkpoint to have a positive altitude? Well, is it the first one where it says it is below sea level? Well, no, sea level is 0. Anything below sea level is a negative number. Is it above sea level? Well, that sounds pretty promising because everything up here is a positive number. Or at sea level? Well, at sea level is 0. So it says, which does it mean for a checkpoint to have a positive altitude? Obviously, it is above sea level, would be your answer for that one. So that's what you need to know for question number 30. All right, the next one, number 31, it says find the surface area of this rectangular prism. So you know it's a prism because it's three-dimensional and the opposite sides are the same shape. It says be sure to include your correct unit in your answer. All right, sounds good. So we look at this and our block, okay, has a front, okay, and a back. Okay, so here's the front and here's the back. Okay, so we know that those are the same, right? So the front and the back is going to be 2, 5, 5. So 2 times 5 is 10. And I'm going to write it twice, okay, because 1 represents the number of square feet for the front and number of square feet for the back. Okay, so then let me see if I can grab a different color here real quick. Okay, so for the sides, we have a 2 by 2. Okay, up and down is 2 by 2, which is 4. I'm going to write that twice, okay, because again, that's each one of the sides. And let's use that color there. So then we have the front and the back, which is 5 times 2 and 5 times 2. Side and side is 2 times 2. And then the top and the bottom, well, the bottom is 5 by 2 again. So 5 times 2 is 10. And another 10. So do we have all 6 sides? Yep, we have the front, the back, side, the top, and the bottom. Okay, so all you have to do to figure this out is add them all up. Obviously, 4 tens, if we were to put the tens together, that would be 40. And then if you add 4 plus 4, that's 8. Okay, so obviously 40 plus 8 would be 48. and they told us very clearly that they want us to make sure we have the units. So the units are feet, okay, and of course you're finding area, not volume, so it is feet squared. Anytime you are finding area, whether it be just the area of one side of something or the surface area, it will always be in units squared. So that's your answer for 31. All right, so now we're at 32, and it tells us to simplify. All right, so once again, we're at a situation where when you're adding or subtracting numbers that have coefficients, okay, so that's the number beside a variable. So a coefficient and a variable right together, okay, then you have to look to see if they are like terms. So I'll just take a second here to draw like terms. Really wish I had a pen for this, but like terms. There we go, not too bad for a mouse. All right, so we're going to look at these 10D and 6D. Well, we can combine them. That's good because they both have the same variable. If one said 10A and 10D, we couldn't combine them. That's as good as we can get. If it said 10D and 6L, okay, you couldn't combine them. Doesn't matter. But these do have like terms. Okay, and then one thing I want you to guys to get used to is when you see a subtraction. So it says 10D minus 6D. I want you to start getting used to changing it to an addition problem. So whatever comes after the subtraction sign, okay, change it to an addition sign and make that number negative. The reason why that's handy is because if you look at this, and now at this point we can compare a 10D and a negative 6D. If I had a number line created, okay, I can start at 10D and I could go backwards 6 places, okay, which would get me to 4D, and that would work. Or with this, you can actually start at negative 6D and move in a positive direction 10 places. So you're going to go up past the 0 and go positive 4 more places. So if you make it an addition problem, you can actually kind of do it a couple different ways. But regardless, no matter which way you do it, you're going to end up with 4D as your ultimate answer on this one. So that's how you would simplify 10D minus 6. Okay, so number 33, it said draw the line plot for these numbers. Okay, so on your worksheet, the red X's are not there. And just because it's kind of difficult to always draw kind of small things with the mouse, I went ahead and just did them already. And this is how I got it. So if you look at the section here where it has the 1, I'm just looking at our data, and I have 1, 2, 3, 4 ones. So I went ahead and just drew 4 X's. Okay, and that's how you make a line plot. Okay, so all you have to do is if it says make a line plot and they give you data, just put it in there. The next one is 6, and there's 1, 2 6s, and you can see that I put those down there. The next one, there's only 1 7, so I just put 1 X there. There's 3 8s, so there's 3 8s down here. And then finally, the only thing left is a 9, so I put it right there. So if you're asked to draw a line plot, okay, this is basically what you do. You just kind of put the X's above it. Make sure that you're drawing them about the same size, because sometimes if people are in a rush, they'll draw smaller X's here and like, oh, only 2, and they'll make 2 big ones here. But if you draw them correctly, you can kind of match up at each level and see, okay, well, there's the first level, there's the second level, there's the third level, and you can kind of compare that way. Because if someone asks, okay, in this line plot, which one happens most often? Well, the answer would obviously be the first one, number 1. That's all you have to do for number 33. All right, this is kind of a quick one. Kira types at a rate of 62 words per minute. So 62 words in 1 minute. How many words does she type in 2 minutes? Well, here's our unit rate. They just gave it to us. 62 words in 1 minute. Well, what does it take to get from 1 minute to 2 minutes? Well, you multiply by 2. So all you have to do is do 26 times 2. And if you multiply 26 and 2, this just takes longer to do it than actually say it. Okay, so 6 times 2 is 12. 2 times 2 is 4. Plus 1 more is 5. So it's going to take 52 or 52 words can be typed in 2 minutes. And that's how you find that. So in 2 minutes, 52 words can be typed. And that's how you do 34. Number 35. Christine and Rachel want to find the mean amount of time it takes students in their class to travel to school. Basically, when you're trying to find the mean amount, you are finding the average. Okay, so you're going to add them all up and divide by however many numbers that is. It says the results are shown below in minutes. Use the data to answer the question. Okay, so we're not actually going to even find the mean in this, but we're going to talk about a couple of the main concepts with it when it comes to statistics. All right, so here's the results down below. Here's Christine's sample, and there's Rachel's sample. So how many people did Christine talk to? She talked to 1, 2, 3, 4, 5, 6 people. How many people did Rachel talk to? 1, 2, 3, 4. So not very big sample sizes. Okay, but who talked to more people, Christine or Rachel? Well, Christine did. And anytime you're ever trying to find statistics, the more data you have, the more likely you're going to have an accurate result. Okay, so let's go ahead and start reading these down below and see what they ask us. What is the sample size for Christine's sample? Well, we just said that and we counted them, and there were 6. What was the sample size for Rachel's sample? Well, there was 4 people. Suppose you had to choose one sample to estimate the mean, okay, which means, again, the more you have, the more accurate your average is going to be. Which sample is more likely to give a good estimate of the mean? Well, who has more people that they talked to? Well, Christine did, so that's going to be more likely to be a better estimate. And why is that? Well, it has a smaller mean. No, that doesn't make any sense. It has the larger mean. Those don't really matter, right? It has the smaller sample size. No, that would definitely be the wrong answer, exactly the wrong answer. And then it has the larger sample size. So that would be the answer. So the main concept that you're probably going to see on the test is that anytime you're looking at data, they're going to ask what's going to be very helpful or what's most important when it comes to collecting data and having an accurate result. And that would be to make sure that you have a larger sample size. The larger sample size will always give you a better result. Okay, 36. There are 6 boys and 5 girls in a class. So 6 boys and 5 girls in a class, which means in each class there's 6 plus 5, a total of 11. If you put them together, right? 5 plus 6 is 11. So it says, what is the ratio of all students? Well, we just decided all students are 11 in the class to the number of girls in the class. Well, in the class there are 5 girls. So that's your ratio, 11 to 5. So you just have to read this carefully to make sure you're putting the right stuff down. The next one is for B, what is the ratio of boys? Well, boys is 6, right? We have that right there. And it says to all students. Well, they're not comparing boys to girls again. They're comparing boys to all students. So that would be 6 to 11. All right, so if they compared boys to girls, it would be 6 to 5. Or girls to boys, it would be 5 to 6. But they kept on comparing it to all students in the class. So therefore, these would be your answers. So just be careful when you're looking at ratios to make sure that you're answering them the way that they are asking the question.